Welcome back to my channel, guys. This video is going to be about what is Wasm, as well as what is the Ethereum virtual machine. Basically, this is going to describe the future of computing and how blockchain is going to incorporate future standards that are going to be implemented in blockchain in the future. So one thing to think about what Wasm is, it is standards that are agreed upon on developers and, different software to like standards basically set common rules so everybody can understand each other. But what is Wasm? It is a portable binary code format and computing text format for executable programs, as well as software interfaces for facilitating interactions between such programs and their host environment. So what does that mean, right? We'll have to break this down to get to the bottom of what portable binary code format and corresponding text format for running programs really is. So when we say what is portable software, it is software that is uses porting, which is software adopted to execute in different environments. That's all that really means. So when we say portable software, we're saying software that's used in different environments. So portable, that's part of what the definition already is. So something used in different work environments. Binary code. So what is binary code? High-level programming language versus low programming language. This is something we need to know when we think about binary. High level is high abstraction from direct compute interactions, whereas low level programming language is little abstractions from direct computer interaction, set architecture, etc. So what is abstraction then, right? If we're going to get to the bottom of what this high-level programming versus low-level programming is. Abstraction is like if you think of a human, we know a human has many components, but when we think of a human, we say human. And we know that it contains all the subcomponents. But then we could take any one of those subcomponents and say, oh, like for instance, this is the lung. And we could say that's a subcomponent of a human. So that is one layer of abstraction. So we know that a human is made up of many components, and then an individual component is, one part of the human, and that is made up of many units. The lung is made up of many cells, alveoli, etc. It's made up of many different units that make up what a lung is. So you have all these different units, and then all of them together that has the properties of a lung, we simply say lung. And that is one layer of abstraction. And then we know lungs, heart, liver, all the other different parts, skin, whatever, all that come together to make human is another layer of abstraction. That's all it is a summation of subcomponents that make a greater component. Now in computing, it works the same way. We have machine direct code. So there's certain slots on computer memory, and those are zeros or ones, and a certain sequence can be equal to an A, a certain sequence can equal to a B, or a number 1, 2, 3, etc. So it is nothing more than zeros and ones, and then those some certain sequence will have arithmetic. So, like 1 plus 1 equals 2. And you'll have the arithmetic zeros and ones as well as the ones, and it will run a sequence of events that lead to the correct output of zeros and ones. And that's how you have the logic that is machine direct, the zeros and ones mechanism. And humans do not program in zeros and ones, but we have programming languages that are written in zeros and ones that someone early on made. And, there's like a level here. I think it's called COBOL. I'm not sure. I haven't filled in my computer science understanding to, but I know there's some in between. And then we get C++, Java, etc. And so we started out with machines doing zeros and ones. People wrote programs, they wrote easier to understand formats. And then modern programming languages are built on those formats. And then Wasm, built on top of that, allows for these programming languages to compile to machine direct. So basically, Wasm takes in people's code, like C++, JavaScript, etc., and outputs a Wasm file, which is machine direct. That Wasm file is machine direct. And that's what allows for it to compile extremely fast It compiles low-level bytecode that exists as a .wasm file. This means that the machine can read it really fast. The machine doesn't have to go to this language and then go to this language and then go to this language to interpret what is being written. It just knows to read directly the zeros and ones that are compiled out of the code, the Wasm architecture. And that's what makes it run so fast, is that computers could just go, machine native code can run. So that's what Wasm is. It is a extraction environment that allows for any developer to write in their programming language machine direct files that will be compiled so that machines can run fast in the browser. And that's what allows the computers to work so fast. So what is it? So what is the Ethereum virtual machine? It is a runtime environment. So that Wasm being said, right? This is the way that computing is moving, so that you can run native, extremely fast speeds in your browser. Well, blockchain is going to incorporate these standards as well. Polkadot already has it. Elrond already has it. I think Cardano has it as well. But I know there's a couple of others that are accepting or moving in that direction. And this is where the most developers are in Wasm. So that is one of the reasons why everybody's moving to Wasm. Now, Ethereum wants to move to it, but right now we'll describe Ethereum and then we'll describe what Ethereum as Wasm would do. So a runtime environment Ethereum virtual machine is a runtime environment for transaction execution in Ethereum. It is a virtual CPU that executes bytecode. So once again, Ethereum is the virtual computer that executes bytecode. Developers write in Solidity and it's compiled into the bytecode on the Ethereum distributed computer. So it's a virtual machine, human readable code, right? So that's what Ethereum is. So let's think of it this way. We know the web is architected in this way. Users have an business access layer, and then they have a data layer and the database layer. That's the traditional web. Whereas Ethereum user view, they interact with the web, and that interacts with the Solidity, and the Solidity is interacting with the Ethereum virtual machine, and then that interacts with the Ethereum computer. I think it's called Geth, and they're bound together and cannot be decoupled. So as Ethereum exists right now, the Ethereum virtual machine and communicating directly to Ethereum, that is a layer that exists on the Ethereum computer, the Geth layer, that makes it hard for them to implement Wasm. So when blockchains are going to interact, when blockchains want to add Wasm, right? They're going to, it's the user view, they write code, it compiles to Wasm, and the Wasm interpreter will then broadcast to the blockchain. And this is where you'll be able to use any programming language. This is why it will be powerful when blockchain is using Wasm, because you'll be able to use any of these codes, whereas Ethereum uses Solidity. It's a standalone interpreter, which means that this standalone interpreter could work with many blockchains. So all the blockchains become interoperable when they use Wasm because of this Wasm interpreter. If you write to the Wasm interpreter, it simply compiles and then broadcasts to the blockchain. So that means it could broadcast to any blockchain that is set up with these standards. Remember, these standards means that everybody could understand it. So the Wasm, once all the blockchains move to that Wasm standard, they all will understand each other, because any blockchain could communicate to that, anyone could compile to the code, and that Wasm interpreter can send it to any blockchain that is there to accept the bytecode from the Wasm. So finally, that's what I already covered. So when Ethereum, now the final step here on what I'm covering here out of what is Wasm, what is Ethereum, is we're going to discuss what it means for Ethereum to move to eWasm. And eWasm is going to work similar to how Polkadot or it's basically blockchains working with Wasm. So eWasm, which is Ethereum Wasm, is going to be how any blockchain will work with Wasm, right? And so eWasm is going to replace Ethereum at some point And this is one of the final upgrades to Ethereum. Now, this is a problem I'm going to mention right here, and this is why I'm going here. It's like an upgrade in Ethereum, but it may never happen, or it's going to be a long time from now. And that's one of the reasons that I think Ethereum's competitors will gain ground, because Ethereum might want to move into Wasm, but it's not, even Vitalik said recently, I have a quote, it's a low priority because you can only see a 1 to 2 times improvement, while other upgrades can see a 3 to 100x improvement. So they're focusing on other improvements to the Ethereum virtual machine. But what I think they're missing out here is, it's only a 1 to 2 improvement, but developers can work in a Wasm environment much better, and there's a wider scope of developers that will be able to write to Wasm or compile to this Wasm than are Solidity developers. So that is one advantage that blockchains that are supporting Wasm right now have, is that they'll be able to quickly adopt in new Rust, etc. Blockchain producers. So another thing is, what will Wasm be? It's basically Wasm with non-determination. Blockchains cannot use non-determination because they have to have the nodes agree. So what is determination? We're going to make that. So determination, non-determinism can be in multiple states. It models parallel computing and has multiple outgoing transitions possible. So it could go in multiple directions at once in a computing environment. And that just doesn't work with ubiquitous nodes, because in consensus, we know that nodes need to all agree. So we need a determinism in blockchains. So one state goes to one state, and they all have to agree. So that is, we are in blockchain Wasm, they're not going to have this non-determinism. And I didn't want to go into floating point too much because that just goes into deeper and deeper into the computing computing components of this. And then also another thing is Ethereum Wasm will have metering, which, obviously Wasm doesn't have metering. But Sato, I'm going to point out, Sato fixes this, okay? This is one of the reasons I have been so bullish on Sato particularly, is because Sato is going to fix the metering problem. Like, think about it. Blockchains literally want to scale, and they have a metering thing that slows them down. Well, Sato will not have that because it's architected so that it doesn't have to be slowed down. Whereas Bitcoin and Ethereum are metered so that they on purpose slow themselves down so that they stick to the rules of consensus, where Sato doesn't run into consensus problems even if it's unmetered. And then there's just some other methods used to interact with Ethereum. So that's basically the gist of what Wasm will look like. And the reason why determinism is because all nodes have to agree. So that's just that. Okay, so one more summary. Ethereum virtual machine, correctness, it was made with correctness rather than efficiency. It was made theoretically rather than practically. That is the Ethereum virtual machine as the way developers describe it. Wasm was made with efficiency and quick loading, much wider developer community for the Wasm community. And Wasm is something like a 2x multiplier, and it will increase throughput by increasing the number of transactions that can be added per block. And because of this, compiling to a standard interpreter that turns into direct bytecode from any programming language, and then that bytecode is read by the blockchain itself. So that is a summary. The summary being that Wasm is the standard that blockchains are going to move to. It's an agreed upon standard. It's like a common language that everybody agrees to, and then it compiles to bytecode, which machines understand faster. And blockchains in the future are going to start using this similar architecture where they can use a Wasm interpreter, and then any blockchain, it could be any different blockchain, and the Wasm interpreter will be able to send that data to any one of them because it's the same, it's executing the same bytecode. So that is why it'll work faster, those standards. And we are moving to an interoperable blockchain world where these blockchains could exist next to each other, and then they could accept workloads from each other in a common language with this common Wasm standard. And then bytecode, executable code for their computation. Anything else that I would have to describe on this would be that Ethereum, I think Ethereum's going to put it off, and I think that means that it might lose. Ethereum has, like, the fastest growing developers are the Wasm blockchains. They are the fastest growing in developers. So that is a possible risk to Ethereum's future. But, Ethereum does have plans to move to it, but Vitalik says it's not a priority. So I don't think it's going to happen anytime soon. And that is my summation of regarding what this means for other blockchains. The other blockchains have their own computing environments, etc. But if you are looking into a blockchain to invest in, one of the things you should do, this is none of this is not financial advice, but one of the things you should do is verify that they are going to at some point be able to work with a Wasm interfaces, Wasm bytecode, or that they accept Wasm as running in their computing environment. That is important for any blockchain that you look at in the future. All right, guys, if you like this kind of content, please like and subscribe, and I hope to bring the best educational content that I can to the blockchain space.